Adding energy to a substance will produce the following changes. The specific name for the state change is given in the diagram. So, increasing energy when energy is added to the substance. So, an endothermic process, heat is entering the system. When we go from solid to liquid, which is melting, liquid to gas, which is vaporization, and gas to plasma, ionization. Conversely, when energy is removed, the following changes occur. The energy is removed from the substance, or an exothermic process where heat is leaving the system. To go from plasma to gas is deionization, gas to liquid is condensation, and liquid to solid is freezing. Okay, so in this direction, endothermic, heat is entering the system. If I reverse it, or as you see here, heat is leaving the system, exothermic. We can show these changes of state using a heating curve. This graph that you see is called a heating curve. It illustrates how temperature changes over time as constant heat is applied to a pure solid substance. The one we're looking at in this case is water. So on the x-axis is heat, and as we go from left to right, we're adding heat. Every division here corresponds to 4 kilojoules. So 4, 8, 12, 16, so on. On the y-axis is temperature in degrees Celsius. So you can see we're adding heat here. We start at minus 25. We add heat until we get to 0. So we're below 0. Water is a solid ice. And then we have this change where we add heat and the ice is melting. Then we get liquid water. And as we go from C to D, the temperature is increasing from 0 to 100 degrees Celsius. Okay, and that's liquid water heating up. Then what do we know happens to liquid water at 100 degrees Celsius? It vaporizes. So we have this long period of time where we're adding heat, but the temperature is staying at 100 degrees. What's happening there is the liquid is turning to vapor. We have that equilibrium between liquid and water vapor there. And then above E, between E and F, above 100 degrees, as we continue to add heat, the temperature of the water vapor increases. As we discussed quickly on the previous slide, the sloped parts of the curve between A and B, C and D, and E and F indicate places where the addition of heat increases the temperature. Only one phase exists along the sloped portions. From A to B is solid, from C to D is liquid, and from E to F is gas. The flat parts of the curve indicate places where there's a phase change occurring. During phase changes, heat is added, but the temperature remains constant. BC on the graph is where melting occurs. Ice and liquid water coexist here. The addition of heat is melting the solid ice to liquid water. DE is vaporization. Liquid water and water vapor coexist, and the addition of heat is used to vaporize the liquid to a gas.